In this video, I want to consider special right triangles. The first one that I want to consider is the 45, 45, 90 degree right triangle. So let's draw one. It's an ugly sketch, but it's the best I can do. All right, so there we have triangles isosceles. It's right, and both angles have to be 45 degrees. So there's no profound thing there. But if I call this side A and I call the other side A, they have to be the same. And let's call the hypotenuse, let's just call that question mark. The question is, how does the hypotenuse relate to the length of the legs in this kind of right triangle? Now later on, I'm going to use this to great extent when I talk about the unit circle. All right, so this is not something to gloss over. Here we go. A squared plus A squared equals question mark squared. So I have the sum of the squares of the two legs is equal to the hypotenuse squared. That's straight up Pythagorean theorem. And now I have 2A squared is equal to question mark squared. So what I'm going to do now is I'm simply going to take the square root of both sides. And when I do that, I have question mark, which is the hypotenuse. Now, the square root of A squared just becomes A. But the 2 is not a perfect square, so it has to stay underneath. So what I have is A times the square root of 2. So the point here is this. Given an isosceles right triangle, it has to be a 45, 45, 90. And when I have that sort of case, what I can say is that the hypotenuse is square root of 2 times longer than whatever the leg is. So let's look at an example or two. If I have a triangle that's isosceles and right, so let's say this is 3, and I tell you that it's a 45. Now, if this angle is 45, the other one has to be 45 as well, because we know that's 90, and they have to make 180, so I know that that's 45. That would mean this side of the triangle is 3, and this side of the triangle has to be the square of 3 times the square root of 2. In the end, what that's going to be is the square root of 2 is about 1.414, so it'd be 3 times that number. But what I need is I need you to know this. So let's do another one real quick. If I have an isosceles right triangle here, here's the right angle, and I tell you that it's a 45, 45, 90, and I told you that this was 8. That would mean this is 8, and the hypotenuse, which always is the one that the right angle is pointed to, is 8 times the square root of 2. All right, one more rather important example. If I look at, let me just make a new page here. Okay, let's look at this. If I have a 45, 45, 90 degree triangle again. So here we go. What if I give you the hypotenuse? Let's do an easy one first off. Let's suppose I told you the hypotenuse was 5 times the square root of 2. Well, working backwards, that would be pretty simple. Each leg would simply have to be 5. But what if it isn't that simple? What if I give you, let's say, a 45, 45, 90 triangle, but I tell you that the hypotenuse is, say, 1? Well, let's call this A for a minute. And we know this. We know the hypotenuse. I'm just going to write, let me move the page down a little bit. We know that the hypotenuse has to be the square root of 2 times longer than either of the legs in this kind of triangle. Since I know the hypotenuse is 1, and I know the leg right now is called A, so this would be A times the square root of 2, which means to solve this for the leg, I'd have to divide by the square root of 2. So I would get, coming over here, I would get A is equal to 1 over the square root of 2. And I'm pretty sure your algebra teacher told you can't leave it like this, so we have to rationalize by multiplying by that, and I end up getting square root of 2 over 2 on top. So that's how those things would be solved. Basically, if you're given the leg and you want the hypotenuse is just going to be square root 2 times longer than the leg. And if I'm given the hypotenuse, you're not going to multiply by the square root of 2, you're going to end up dividing by the square root of 2 to figure it out. But it can always be figured out in this case.